So today we are scaling up. We usually talk about home gear where you might have, one or two connections. But this deep dive is about what happens when you need to feed 24 screens from a single source and do it cleanly from a single rack unit.
We're looking at the Thor Broadcast HSP-1x24. And it really is the difference between, say, a messy daisy chain of cheap splitters and a professional head-end setup.
The scale is the first thing that just jumps out at you. A 1 by 24 unit, one input, 24 outputs. But the spec sheet calls this a splitter/combiner. Now, the splitting part I get. One antenna feed going to every room in a hotel. But combining, why would I ever need to combine 24 signals into one?
That's where the commercial application really kicks in. So think about a specialized head end. Maybe you have multiple modulators or different security camera feeds, internal information channels. You can actually use this unit as a 24-port generic RF mixer. Funnel all of those different signals onto a single trunk line.
Oh, so it's bidirectional. You can push water out to all the sprinklers, or you can drain the whole field back into one pipe, so to speak.
Precisely. It gives you a ton of flexibility, but if you're looking to install this, you really have to look closely at the frequency support because there is a bit of a catch compared to the smaller units.
Right, I noticed that. If you buy the little 4-port version of this hardware, it goes all the way up to 2100 millihertz. But this 24-port monster, it caps out at 1000 millihertz. That feels like a pretty big downgrade for a bigger unit.
Well, it's not so much a downgrade as it is a specialization. That frequency cutoff tells you exactly what this unit is for. You aren't running high-frequency satellite feeds through this. Satellite signals, they operate in that higher range. This is a dedicated beast for standard CATV and antenna signals. It's trading bandwidth for port density.
So if you're trying to wire up a DirecTV system, this is the wrong box.
Exactly. This is for cable and terrestrial antenna, period.
Okay, but let's be real about the physics here. You're slicing the pie 24 ways. That signal has to be barely a whisper by the time it leaves the box.
And you're right to think that. The spec sheet lists a negative 12.5 dB insertion loss. In the RF world, that is. That's massive.
Wow.
Yeah. So if you don't have a high output amplifier driving the input, you're just going to be sending snow to 24 screens. This isn't passive magic. You need some serious juice at the source.
Okay, moving on to the build itself. We're looking at standard F-type ports across the board, so compatibility is not an issue. But with 24 lines coming into one rack, my immediate worry is safety. What happens if lightning hits the antenna?
And that is exactly why the grounding block is integrated directly into the chassis. In a professional rack, especially one connected to outdoor equipment, that physical path to ground is, well, it's non-negotiable.
I also saw a warning in the specs. No DC passing. Is that a limitation or is that another safety feature?
In a setup like this, it's a safety firewall.
A firewall?
Absolutely. Sometimes an upstream amplifier will push voltage down the same coaxial line to power a remote device. You do not want that voltage leaking into your 24 different TV tuners. This unit physically blocks that current. Only the RF signal gets through. The voltage stops at the gate.
That makes perfect sense. You don't want to fry 24 TVs because of one upstream amp. Now, usually when we get into rack mount professional territory, the price tag gets ugly.
Surprisingly, not here. It's currently priced around $295, down from about $350.
Really?
Yeah, for a 24-port mixer with a 2-year warranty, that's very accessible, even for a small business or, frankly, a really high-end home enthusiast.
It effectively solves that one signal, mini screens problem without needing a degree in cable management.
And it's a good reminder that the infrastructure matters. We all obsess over the 4K resolution on the screen, but we totally ignore the plumbing that gets the signal there in the first place.
That's the perfect takeaway for me. It makes you look at your own walls a little differently. So when you're watching TV tonight, just ask yourself, how much insertion loss is happening in your own attic right now? How much of that original signal actually survived the journey? Thanks for listening to this deep dive, and we'll catch you on the next one.